Welcome to Lesson 9 of Apache Mastery, the one where we crack open the engine room. So how does Apache actually serve 100 requests at once? A multi-processing module decides, and there are exactly 3 choices: prefork, worker, and event. Pick the wrong one, and you'll either burn 4 times the memory you need or break PHP outright. So today we're going to make that choice mechanical. Here's the roadmap. 4 pieces in order. First, what an MPM actually is. Apache's concurrency core, and only one is loaded at a time. Second, the 3 flavors: prefork, worker, event, each a different era of thinking about concurrency. Third, the handful of knobs that actually matter, where MaxRequestWorkers times threads per child gives you raw capacity. And fourth, the decision itself, which MPM for which workload. Get those 4 down, and capacity planning any Apache box becomes arithmetic. And here's that matrix, the single most important slide in this lesson. 3 columns, 3 eras of Apache concurrency. Prefork spawns a whole process per request, 10 to 30 megs each, only justified if you're stuck with mod PHP. Worker mixes processes and threads, drops you to about 3 megs per thread, but honestly it rarely gets picked anymore. Event is the modern default, async I/O, around 2 megs per thread, perfect for static content, reverse proxying, or PHP-FPM. Same hardware, 4 times the memory cost if you choose wrong. Let's zoom in on prefork since it's still out there in the wild. The mental model is dead simple: a master process that never serves traffic, and a pool of children where each one handles exactly 1 request at a time. The config knobs control that pool. Start with 5, keep at least 5 idle, cap the whole thing at 150. And that cap is where the math bites. 150 workers times roughly 25 megs each is nearly 4 gigs of RAM just to stay online. Now compare that to event, the modern default. Instead of 1 process per request, you get a handful of processes, each running many threads, plus 1 async listener per child, whose only job is babysitting idle keep-alive connections. The math tells the story. 400 concurrent requests served by 16 processes at 80 megs each, about 1.3 gigs of RAM, 3 times cheaper than prefork, and it absorbs 10 times the keep-alive load. So how do you actually pick? In practice, there are only 3 workloads you'll meet. If you're running WordPress with mod PHP, prefork is your only safe option. The PHP interpreter lives inside the process and isn't thread safe, so sharing it across threads will crash you. For a static site or doc server drowning in idle keep-alives, event wins by a factor of 10. And for anything modern, PHP-FPM, Node, a reverse proxy to a backend, event again, because async I/O frees threads while the backend does the real work. Knowing the verdict is one thing. Executing the migration without taking the server down is another. Confirm you're on prefork first. Then, the trap. If mod PHP is loaded, swapping the MPM before swapping PHP will refuse to start Apache. So install PHP-FPM, disable mod pp, enable proxy.fcgi, and activate the FPM config. Only then flip the module from npm tx prefork to npm backslash event, run config test, and restart. 3 steps if you're pure static, 6 if PHP is in the mix. So step back for a moment and ask the deeper question: why does Apache still ship 3 MPMs when Nginx bet on 1 and never looked back? 3 reasons. First, backwards compatibility is a feature. Millions of moddy PHP WordPress sites from the pre-thread safety era still depend on prefork, and Apache refuses to orphan them. Second, no single concurrency model wins every traffic shape. A static site at 10K requests per second wants event. A heavy CRM with big payloads wants worker. A legacy PHP stack wants prefork. And third, switching between them is a 2-command config change, not a vendor migration. That last part is rare in this world, and worth a lot. With the model picked, Here are the 7 knobs that actually matter when you tune it. The one you'll reach for constantly is MaxRequestWorkers. That's your hard ceiling on concurrent requests, and it's where capacity planning lives or dies. The one to handle with care is max connections per child. It recycles a worker after n requests, which is really a graceful workaround for leaky modules. Everything else? Threads per child, server limit, start servers, the spare thread pool, and the async factor for event is supporting cast that shapes how those 2 main dials behave. Time to put all of this into your hands. 3 drills building on each other. First, 5 minutes to identify which MPM your server is actually running and what its current concurrency ceiling is. Then 10 minutes on the capacity math, RAM divided by process size, times a safety factor, to see whether your MaxRequestWorkers is sane or a time bomb waiting for the killer. Finally, 15 minutes in a lab VM to actually migrate prefork to event with PHP-FPM. Do all 3, and you can audit any Apache box in production with confidence. Before you go off and tune, learn from 5 mistakes that catch almost everyone. 1. Switching to event while mod PHP is still loaded. Apache seg faults because mod PHP isn't thread safe. Move to PHP-FPM first. 2. Setting MaxRequestWorkers higher than RAM allows and meeting the killer at peak. 3. Keeping 50 idle spare servers on a quiet site, burning a gigabyte for nothing. 4. Editing threads per child and running reload. That directive is read at process start, so you need a full restart. And 5. Copying tuning numbers between MPMs, where 400 workers on event becomes 10 gigabytes on prefork. Different scales, different math. And that's the MPM picture. 3 models, the knobs that matter, a clean switch workflow, and rules for picking honestly without guesswork. The choice should feel mechanical now. Prefork if mod PHP pins you, event everywhere else, worker only when you have a reason. Next lesson, we turn to logging, access, error, and custom log formats, because once concurrency is right, you need to actually see what your server is doing. See you in Lesson 10.